It might feel complicated at some point, but the concepts are actually pretty simple. So just be a little patient with yourself, and we'll practice it some more next week as well. I know it's a Friday, so we'll bring your brains back on Monday and practice it again, okay? So we're going to start looking at, we're going to not do compositions today. So stepping away from compositions for a minute, we're only going to combine functions. So we're going to add, subtract, multiply, divide, but we're going to focus on domain, okay? So when we think about domain, we want to think about what values my function is defined for. So what values can you plug into the function, okay? And the things we really want to consider when we're thinking about domain is, do we have any zeros in the denominator? Because are we allowed to divide by 0? Is that an okay thing to do? No. So zeros in the denominator are bad. And then the other bad thing that we usually see is we are not allowed to have what under radicals? What causes a problem under radicals? Negatives. So negatives under radicals will also cause us problems, okay? So that's what we're looking for when we want to look for the domain, is to make sure those things don't happen, okay? So when you look at a function and you're thinking about the domain, the first thing I like to ask myself is there a radical, okay? We'll deal with the radicals here in a second. If there is no radical, your answer is going to be pretty much all real numbers for the domain, okay? But you may have to exclude just a couple values. So if there's no radical, you're usually going to have the all real numbers will be the domain, unless you have a denominator, okay? So if there is a denominator, so if there's no radical, your domain will end up being all real numbers. So we can use the all real numbers symbol here, or you can do negative infinity to infinity, whichever one you prefer. They mean the same thing. Okay, that's like a double R thingy for all real numbers. And then if you have a denominator, there's going to be a couple of exceptions. So we're going to say all real numbers except. And then we got to figure out what those exceptions are. So if we want to figure out what those exceptions are, we want to look at what's going to make the denominator 0. So if we take those things in the denominator and we set them equal to 0, that will give you your exceptions, okay? So if there's the denominator, you're going to set that denominator equal to 0, and that will give you your exceptions. We'll look at an example of this in a second, okay? If there's a square root, that changes. You're not going to write all real numbers for the domain if there's a square root. And depending on where the square root is, your domain will be different, okay? If the square root is in the numerator, okay, you're going to set the domain will be whatever's under the radical. Whatever's under the radical will be greater than or equal to 0. If we're looking at a square root in the denominator, your domain will be whatever's under the radical greater than 0. You're just not going to do the equal to symbol, because if it's the radicals in the denominator, we also don't want it to be 0. So the only difference between a radical in the top and the bottom will be the equal to versus a not equal to. Otherwise, those are basically the same. So we'll look at some examples of these. So basically, when you're thinking about domain, you want to ask yourself, are there radicals? Is there any denominators? Okay, those are the two questions you want to ask yourself. So let's look at this first one here. For this one, we want to ask ourselves first, are there any radicals? Are there any radicals here in this one? Is there any radicals? No. So then our domain will start with all real numbers. If there's no radicals, we'll start with all real numbers. But we need to see if there's any exceptions, and there will be exceptions if there's a denominator. Is there a denominator here, something in the bottom of the fraction? Yes. There's two things in the bottom of the fraction here. So what are you going to do with those? You're going to take those, and you're going to set the denominator equal to 0. Okay, so you're going to take x plus 3, set it equal to 0, and you're going to take x minus 4 and set it equal to 0. And then you'll solve each of those equations. So for this first equation to solve for x, I'll subtract 3 from both sides, and I'll get x equals negative 3. And for this equation, what will I do to both sides? Add 4, and we'll get x equals 4. And these two numbers are going to be your exceptions, okay? Because we don't want the denominator to be 0. If I plug in negative 3 right here, I will get 0 times the number, and the denominator will be 0, and that's bad. If I plug in 4 right here, I'll get 4 minus 4 is 0, times another number, that will be 0, and I will have a 0 in the denominator, and that's bad. So these are our exceptions. So then your answer for the domain will be all real numbers except x cannot be negative 3, and x cannot be 4. So we're putting the not equal to symbol, we're putting the slice through the equal to say not equal to. So any other number is okay to plug into that. The domain will be any other number except negative 3 and 4, okay? So if there's no radicals, you're just going to look to see if there's exceptions for the denominators, and otherwise it will be all real numbers. If there isn't any denominator and there isn't any radicals, it will just be all real numbers. Any questions about that first one? All right, so now for this one, do we have any radicals? Yes. So when we go to do our domain, it's not going to be all real numbers. We're going to have something else instead. So how do we figure out what the domain is? Well, if it's in the numerator, you're going to take what's under the radical and make it greater than or equal to 0. So what's under the radical here? X minus 6. So you're going to take x minus 6 and make it greater than or equal to 0, because we want what's underneath here to be positive, right? So we need all of this to be positive, but it could be 0 as well. You're allowed to have a 0 under the radical as long as it's not in the bottom, okay? And then we're going to solve this inequality. We solve inequalities just like equations. We're going to move the 6 over. How will we move the 6 over? Plus 6. And now x is by itself. And so we're done solving that inequality. And this is going to be the answer to your domain. X has to be greater than or equal to 6. Any questions on that one? So if there's a radical, your domain will not have all real numbers in it, right? Because you are now saying it has to be everything greater than or equal to 6. As long as your number that you plug in here is bigger than 6, you'll have a positive under that, so we'll be okay. But if you plug in like 5 there, you're going to have a negative, right? So that's why x has to be greater than or equal to 6. It can be 6, because if you plug in 6, you'll get 0, and square root of 0 is just 0, and that's okay. So now for C, do we have any radicals? Always ask yourself about radicals first. Yes, we have a radical, but this one is in the top or the bottom? Bottom. So you're going to do the same thing. You're going to take what's under the radical, and you're going to set it greater than 0. You're just not going to put the equal to underneath. That's the only difference, because it can't be 0 because it's in the bottom. Okay? So you're going to take x plus 5 and just make it greater than 0. And then we'll solve that, and that will give us the answer to the domain. So what will I do to solve this inequality? Subtract 5, and we'll get x is greater than negative 5. So that will be the answer to your domain. So the only difference if the radical is in the bottom is you don't keep the equal to underneath, because it can't be 0 in the bottom. That would be a problem, because it would be a 0 in the denominator. Any questions about these three? These are the three main situations you're going to run into. So no radicals, something in the bottom, radicals in the top, and radicals in the bottom. Any questions about those? All right, this last one's a little interesting, because do we have a radical? It's in the top, so we'll start with that. but then we also have a denominator. So this one's kind of a combo of these things up here. So that's why this one's going to be a little more confusing. But this is as confusing as it will get. And then we don't see this very often. So we do have a radical. So we'll start with the radical. It's in the top. So are you going to do greater than or equal to 0 or just greater than? Greater than or equal to, because it's in the top, right? So if it's in the top, you always put the equal to. So we'll take what's under the radical, x plus 2, make it greater than or equal to 0. Subtract 2 from both sides. And we'll get x greater than or equal to negative 2. So this will be the start of our domain. X greater than or equal to negative 2. But we do have a denominator here, right? So we're also going to have an exception, okay? So when you have a denominator that's not a radical, you're going to have an exception. So we're going to have an exception. And what do we do to figure out what that exception is? What do we do with this thing in the denominator? Set it equal to 0, right? Because that's what's bad with things that are not radicals, right? Just like you set these equal to 0 over here, you're going to set that x plus 5 equal to 0. And you'll get x equals negative 5 if you solve that. So that will be our exception. So x cannot be negative 5. Now, some of you might be thinking, do I really need this exception? This says that the domain has to be x greater than or equal to negative 2. Is negative 5 greater than or equal to negative 2? No. So really, you don't have to write this exception. You could just leave it off because that's not in your domain in the first place, right? But if you want to be safe, you could always just leave it there. It's just extra information, right? It's not wrong. It's just extra information. So you can always just leave it there. But if you're thinking, that doesn't make any sense, why do I need to take out negative 5? It's not in my domain. Then that's fine. You don't need to write it, okay, if that confuses you. But you can leave it in there. It's just extra information. Any questions on that one? Okay, let's have you guys try a couple now. So there's 4 more at the bottom. I'm going to have you try them, and then we'll go over them together. So for this first one here, we have a radical, right? So the first thing you want to look for is a radical. This radical is in the top, right? There's no denominator here. So when you go to do this one, you're going to take what's under the radical and you're going to set it greater than or equal to 0. So check to see if you had the equal to here. You do need that for this one because the top can be 0. When you subtract 2 here, you'll get x is greater than or equal to negative 2. So that will be our domain here. So check to see if you got x greater than or equal to negative 2 for A. Any questions on that one? For B, we don't have any radicals, right? So we don't need to set anything greater than or equal to 0 or greater than 0. So our answer for the domain will start with all real numbers because there are no radicals, okay? But then we need to look to see if there's any exceptions. And we do have 2 exceptions because there's 2 things in the denominator. So when you have exceptions in the denominator, you set those equal to 0 because we cannot have a 0 in the bottom. So we'll get one exception is x equals 1. So x cannot be 1. And then our other exception, subtract 5 here, and you'll get x equals negative 5. So x cannot be negative 5. Make sure that you are putting a not equal to symbol here. I know you get equal here, right? But this is where we're figuring out what makes the denominator 0. And we don't want zeros in the denominator. So that's why we put a not equal to, okay? Do I need to set the x plus 2 equal to 0? Does this need to be equal to 0 up at the top? Why not?
Because it's in the numerator.
It's in the numerator. It's not in the denominator, right? So it's only if it's in the bottom that you have to set it equal to 0, right? To find the exceptions. Okay? For C, we'll look for radicals. So we do have a radical here, x plus 2. So we will set that greater than, so our domain will not be all real numbers. We won't start with all real numbers. We'll do our greater than or equal to thing. Do we want an equal to on this one, or do we want just the greater than? Just greater than, because it's in the bottom. We don't want it to be equal to 0, right? It cannot be equal to 0 because it's in the bottom. So that's the only thing that changes if your radical's in the bottom. Just don't put the equal to underneath. So we'll subtract 2, and we'll get x greater than negative 2. So our domain here will be x greater than negative 2. Do I need to set this x plus 1 equal to 0 for an exception? Is it in the bottom? Nope, so it doesn't need to be an exception, right? It's just hanging out in the top. So exceptions should only come from denominators, okay? Just in the bottom. And then D is an interesting one because it's a combo, okay? We start looking for radicals first. We have a radical up here in the top. So we'll take x minus 1 and we'll make it greater than or equal to 0. It's in the top, so it can be equal to 0. So check to make sure you had that equal to symbol here on x greater than or equal to 1. So you'll start your domain with x greater than or equal to 1. But then we also have a denominator. So do I need to find an exception here? Yes, because x plus 3 is in the bottom. So here I will have an exception. So I'll set x equal to, or x plus 3 equal to 0. Subtract 3, and you'll get x equals negative 3. So we have an exception. I don't know why I wrote exception. Just accept is what I really wanted to write. Except x cannot be negative 3. Now, again, if you feel like that's extra information, it's true. It's extra information. It's unnecessary in this problem. So if you wanted to leave that off, you could, because we're only considering everything greater than or equal to 1 in the first place, okay? But first, just if that is confusing, just write the exception down. It's just extra information. Any questions about any of those? So domain, not too hard, right? Just radicals and zeros in the denominator is all you're looking for. So now let's go ahead and we're gonna talk about domain some more. We're gonna practice with the domain some more, but we're gonna start combining some functions here. So we're going to find a combination. So these are all combinations. We don't have any compositions here, so no circles, right? These are just gonna be combinations because it's like putting two things together, right? Here, what are we going to be doing with our functions? This isn't a composition. What is this? We're adding. Here, what are we going to do with our functions? Multiplying. Here, we'll add. Here, we're going to subtract. Here, we'll multiply. Here, we'll divide, right? So there's no composition here, right? No f of g of x. There's no circles, okay? So no compositions, just combinations. So we're going to combine the functions together, and then we will also practice answering what is the domain of our answer, okay? So we'll be giving the domain of our answer. So let's start with this one here, and just a reminder of what this means. This means f of x plus h of x. So we're just going to simply take the f function and the h function and add them together. So what is our f function here? X minus 3. So if I'm trying to find f plus h, I'm going to write that just kind of shorthand here. We're just adding f and h together. I'm going to take the f function first, x minus 3, and then I'm going to add the h function to that. What did they say the h function is? X plus 1. So I'm just going to add x plus 1 to that. If I can simplify, I should. So can I add these together? Yeah, what can I add together? The x is x plus x, though, not times x. X plus x, so what is that going to be? 2x. You're not multiplying, you're adding, right? So it'll just be 2x. X plus x is 1x plus 1x, which is 2x. And then negative 3 plus 1 will give me negative 2. So there's two answers we're going to be giving for each of these questions. One, we're going to find the combination. So here, that's what we did first. We found F plus H. This is F plus H. Because you just added F and H together. Then we're going to find its domain. So our answer here, we're looking for the domain of our answer, the combination, this guy right here. So this is what you're going to be describing the domain of. So first we look for radicals. Are there any radicals here? No, right? So our answer will start with all real numbers. Do we have any denominators here? Do we have any denominators that we need to make exceptions? No. So there's no exceptions at all. So guess what the domain is? Just all real numbers. That's it. So if there's no radicals and there's no denominators, it's just all real numbers. There's no exceptions needed. That's the domain. Does that make sense? So that's your second answer here. So you're giving me a combination of two functions, 2x minus 2, and then you're describing the domain of that answer. Does that make sense, what we're doing? Okay, let's do this one here. What does this mean when they're sitting next to each other? What are we going to do with f and h? Multiply. So this means right here, f of x times h of x. Just a reminder of what that means. No composition. You're not putting it inside the other function. You're just multiplying. So to find f times h, I'm going to write shorthand here. F times h. We're going to take f. What did we say f was? X minus 3. And we're going to multiply that by h. So now we're multiplying these two things together. What are you going to have to use to show me that you're going to multiply these two whole things together? Parentheses. You need to use parentheses here to show me you're multiplying x minus 3 times x plus 1. We're not just adding, we're multiplying. So we want to multiply this whole thing by that whole thing. I think you know what to do here, right? What do we need to do now? Yeah, distribute that out. We can simplify this. We can distribute to your box method or your FOIL or just distribute. Go ahead and practice that. So you should get x squared minus 3x plus 1x minus 3. And then you can combine these two middle terms. And you should have x squared minus 2x minus 3 as your final answer for what f times h is. This is our combination. So this is our first part of the answer. Any questions about how we got that with the distributing at all? I think y'all have been doing pretty good with that. Okay, then we need to answer the second part of the question. What is the second part of the question asking us? What is the domain of this answer, right? Are there any radicals here? Are there any denominators here? So what is the answer? Just all real numbers. Pretty easy for that one. Any questions? All right. Now let's do f plus g. So this is going to be f of x plus g of x is what this means. Shorthand, I'm just going to write f plus g. So f is what function? X minus 3. And what is g? Square root of x minus 2. So we're going to add the square root of x minus 2. Can I add these x's together? Can I add the negative 3 and the negative 2 together? So is there anything I can do here? No, this is it. That's all you can do here. There is nothing more to simplify. This is f plus g. That's all we can do for that one. That's it. You can't go under the radical and add the things that are outside the radical, right? So there's no simplifying you can do for, so this is the answer for part 1. And then we need to find what? Domain of our answer. Does this whole thing have any radicals in it? Yes, right? And it's in the top, right? There's no denominator. So what are we going to do with that x minus 2? X minus 2 is greater than or equal to 0. That's how we'll figure out the domain. You don't need to worry about the x minus 3. It's not under the radical, right? It's not in a denominator. So just take the x minus 2, set that greater than 0, add 2, and you'll get x greater than or equal to 2. So the domain here is x greater than or equal to 2. Does that make sense? All right, try C on your own now. F minus g. This means f of x minus g of x. So you're going to find f minus g, and then you're going to tell me the domain of that answer. So when you do f minus g, f is going to be x minus 3. G is going to be the square root of x minus 2, so you're going to subtract that. Is there anything I can do to simplify that at all? Can't go under the radical, right? So that one's done. Not much work there. When I go to do the domain, first look for radicals. Do I have radicals here? Yeah, I have an x minus 2 under a radical. So you're going to take that x minus 2, set it greater than or equal to 0. It's in the top, so it'll just be equal to. There's no denominator here. Add 2 to both sides. X greater than or equal to 2 should be your domain. So you're just looking at your answer to see if you have radicals or denominators, right? Just like we did with the original problems on the front page. You're just looking at your answer now for radicals or denominators. So these two had the same domains because they both had an x minus 2 under a radical, right? So those have the same domains. All right, let's do some division. Or no, sorry, we have another multiplication. Oh yeah, let's do a multiplication here. This one with a radical. This one's not too bad, but it might feel a little confusing. So this means f times g of x. So first we'll find f times g. I'm just going to write that in shorthand. So f is x minus 3. And then we're going to multiply that whole thing by the square root of x minus 2. Now, if you left it like that, that's not unreasonable. I can see why you would leave it like that. Sometimes you might see the answer written like this, okay? But we can actually do a little bit of multiplication here. There's not a whole lot we can do, because if I try to distribute, I can't do the x times the x and the x times the negative 2, because those are under the radical, right? But I can do x times this whole thing, okay? So I can distribute a little bit. I can do x times the whole thing. So that'll be x times the square root of x minus 2. And I literally just write it like that because that's all that I can do. X times that whole thing. I can't do the x times this and the x times that because that's inside. So I can't like go all the way with the FOILing. But then I also can multiply the -3 by this whole thing. I can't do -3 times that and -3 times that, but I can do -3 times the square root of x minus 2. So usually this is how you'll see the answer. You can't do anything else from there. If you were thinking you just needed to leave it like that, I don't think that's unreasonable thinking, but we can do a little bit of multiplication there. And then we'll do our domain here. We have a radical, x minus 2. It's the same thing under both radicals, so we just need to worry about x minus 2. It's in the top, so it should just be greater than or equal to 0. Add 2, and we get x greater than or equal to 2. So your domain, again, will be x greater than or equal to 2, because it's the same thing under the radical for the last couple problems. I think the division ones are where they get the most complicated. So not like the math is actually really easy, like putting them together, but just the domains. So let's do a couple division ones. So for D up here, we're going to do F divided by H. So F is x minus 3. H is x plus 1. And the nice thing about the division is usually there's no simplifying. Like we can't divide those. So that's it. So this finding the combination usually is very easy for division. It's just F divided by H. The domain is where we tend to get a little more complication. So when I look at this one, do we have any radicals? No radicals. So we'll start with our domain as all real numbers. But do I have an exception here? Yeah, do I have something in the denominator? X plus 1, right? So take that exception and do what with it? Set it greater than 0 or equal to 0? Just equal. That's all we want. We just want to know when it's 0. It's not under a radical, so we don't need a greater than symbol. Just equal, and we'll get x equals -1. So our exception here is that x cannot be -1. Any questions on that one? Let's do a couple more quick division ones because these are pretty quick. So we're going to do F divided by G this time. So you'll have x minus 3 in the top. And what will we have in the bottom? Square root of x minus 2. Again, there's not really anything you can do there. So that's your answer for the combination. Do I have a square root here? Yeah, so I need to set some x minus 2 greater than 0. Should it be greater than 0 or greater than or equal to 0? This is just greater than, right? This is the one situation where you drop the equal to sign because where is the radical? It's in the bottom, so it can't be equal to 0. So you don't want that equal to there. So your domain will just be x greater than 2. Do I need to do an exception for the x minus 3? Do I need to set that equal to 0? Do I have to worry about this? No, because where is it at? It's in the top. We don't care about the top. The top can be 0 all at once. We just care about the bottom. So last one here, we'll do G divided by F. So that'll be square root of x minus 1 in the top. and x minus 3 in the bottom. Oh, thank you. X minus 2 in the top. Square root of x minus 2. So your domain here, this is one of the interesting ones. You'll have x is greater than or equal to 2 because of this, and then the exception and on top of that. There's a homework at the back if you want to grab it. All right, so this one here, remember, means f of x plus g of x. But I'm just going to go ahead and write shorthand here that we want to find f plus g. So f is 2x plus 1, and g is x minus 3. So we'll add x minus 3. We can combine some like terms here. 2x plus x will be 3x. 1 plus negative 3 will be negative 2. And then we cannot combine 3x and minus 2. So this one is done. So this is our first part of the answer. We found f plus g. And then we're going to take this answer and we're going to look at the domain of this guy right here, our answer. So is there any square roots? No, there's no square roots. So we'll start with all real numbers. And then we just need to see if there's any exceptions. Are there any denominators? No. So there's no exceptions. So this is our domain. For b, we're doing f of x divided by g of x. That's what this means. Shorthand, I'm just going to write f divided by g. So f is 2x plus 1, and g is x minus 3. There's no simplifying you can do here, so this is your first, the answer to the first part. The f divided by g, we found the combination. And then second part, we need the domain of this answer, right? This guy right here, this answer. So does this answer have any square roots? No. So we'll start with all real numbers. But are we going to have an exception here? Yes, because we have a denominator here, right? X minus 3. So we're going to have an exception. So we will have except, and then we need to figure out what that exception is. So we're going to take x minus 3 and set it equal to 0, add 3, and we'll get x equals 3. So our exception is that x cannot be 3, because that will make the denominator 0. If you plug 3 into this denominator right here, 3 minus 3 will be 0, and that will be a problem. So x cannot be 3. Here for b, we're doing f of x minus h of x. So in shorthand, I'm just going to write f minus h. So f is 2x plus 1. H is the square root of x plus 1, so minus the square root of x plus 1. I can't go inside this radical and do 2x and x because those are both, one's underneath and one's outside. I can't do 1 and 1 because one's inside. I'm not multiplying, so I shouldn't be distributing. So this is just the answer. There's nothing else you can do to simplify this part. So this is the answer to the first part, the combination, find f minus h. And then we need to answer the domain for this answer, right? So we're looking at our answer here, this whole thing, and asking ourselves, what is the domain of this? Well, we want to look for square roots first, and we do have a square root. There's a square root right here. So our domain will not say all real numbers. Instead, we will take x plus 1, and because it's in the top, it's not in the bottom, we're going to say greater than or equal to 0. Solve the inequality, and our domain will be x is greater than or equal to negative 1. So that's part 2 of our answer. And then over here, we're going to be doing f divided by h. So I'll write that in shorthand here, f divided by h. F is 2x plus 1. H is the square root of x plus 1. There's nothing you can do to simplify this, so that's the answer to the first part. For the second part, we're going to be looking at the domain of our answer, so this guy right here. Do we have any square roots? We do. There's a square root right here in the bottom. So since it's in the bottom, we're going to take it, what's under the square root. We make it greater than 0, but don't put the equal to because it's in the bottom. So it cannot be equal to 0. So just leave out the equal to. Then we'll subtract 1. And we'll get x is greater than 1. So our domain starts with x is greater than 1. And then we can ask ourselves if we have any exceptions, but the only thing in the denominator was the square root. So we don't have any other exceptions. So this is the answer to our domain.